This video goes through completing the square. Now we're going to use it to factorise quadratics. We can also use it to turn a quadratic into turning point form, and we can also use it to solve a quadratic and find x-intercepts. The reason for it is usually when we have irrational solutions, when they can't be factorised by using our cross method, for example. Now we're going to use the perfect square formula like the name suggests, completing the square. And I have the two perfect square formulas here. A squared plus 2ab plus b squared is a plus b all squared. And a squared minus 2ab plus b squared equals a minus b all squared. Now, I do take a little bit of a different approach. I don't try and do it all in one step. And what I'm going to do to start with is actually rearrange that formula so you can see what my process is. So all I've done is I've gone and put the 2b in front of the a, right? Because what I'm going to do to be able to complete my square, I already know what a is. Okay, so that's fine, but I need to know what b is. So I'm going to get whatever the coefficient of a is, in this case 2b, and I'm going to divide that by 2 to get my b. Once I've done that, I've set my bracket up. Now that's the same if I have a negative or a positive, it's just that I'll take the negative if it is. So anyway, I'll go through the process and hopefully that makes more sense for you. So let's look at two examples. We're factorising by completing the square, and down the bottom I have the formulas. I have those perfect square formulas so you can refer to them as I go. Now I don't do this in one step. My first step is to determine what my perfect square would be, and then I deal with making my x squared plus 4x plus 1 a perfect square. Right? So when I look at this, I look at that coefficient of x, remembering that's my 2b if I look at that formula down the bottom. So I want to know what b is. So I'm going to go 4 divided by 2 is 2. I want to square that so I know what my b squared would be, and that would be 4. So my perfect square is x squared plus 4x plus 4, my b squared, equals my x plus 2 all squared. So that 4 being my b squared goes there, and that 2 being my b goes there. Now, that's a step you might not see others do. I like doing it because you get what you need and then you start manipulating. So what I actually have is x squared plus 4x plus 1. That's what I want to factorise. I don't know how to factorise it. What I know how to factorise is x squared plus 4x plus 4. So I just need to make these two sides equal. And to do that, okay, I go, well, I want a plus 1. Well, if I take away the 4, I've got 0. I can now add the 1. Those two sides are now the same. What I want to do now is I want to replace what I know I can factorise. So that x squared plus 4x plus 4 is x plus 2 all squared. And then the negative 4 plus 1 is negative 3. Now I have a difference of perfect squares. Remember the formula a squared minus b squared equals a plus b, a minus b. I have two perfect squares and I have a minus in the middle. Right? So I can use this formula to factorise further. So my x plus 2 is my a, if I want to think of the formula. And then the b is the square root of 3, remembering that the square root of 3 all squared is 3. So I have plus the square root of 3 minus the square root of 3. And that is now factorised. Now, what else could a question ask you? Well, it could have asked you to just put that quadratic into turning point formula or turning point form, or it could have asked to find the turning point. Now note that is there. That's that x plus 2 all squared minus 3. My turning point, or my vertex, of my parabola would be -2, -3. That parabola, if I think about my translations, is moving 2 to the left and 3 down. If I was asked to solve, so maybe it said solve x squared plus 4x plus 1 equals 0, I'd get my fully factorized form, and that needs to be 0. And using my null factor law, my x is going to be -2 minus √3, and or x is going to be -2 plus √3. Right? And if then you could sketch, they're your x-intercepts. Now, another thing, note that you have to have a minus here to fully factorize. If that is a plus, you can't go any further. So pause the video and have a go at the next one on your own, just following the steps. Now, it's like a recipe, the same steps every time. So the more you do, the more you'll get to know that recipe and you'll be able to do it without any issues. So pause the video, have a go. Okay, so hopefully you've tried. You should have started by saying, okay, I need to get that -x because that's my 2b. And I need to divide it by 2, and that's -4. And then I need to square that -4, and I get 16. Right? So I know my perfect square is x squared, take 8x plus 16 equals x minus 4 all squared. Now you can expand your brackets and check that you're correct. Okay, so that step's just working out what that b term is and the b squared. I now go, okay, well, I want to actually factorize x squared minus 8x minus 3. I know how to factorize, x squared take 8x plus 16. So I try to make those two sides the same. So I take away the 16, so it's 0. I want minus 3, so I take away 3. So those two sides are the same. I now replace my perfect square. So I've got x minus 4 all squared. -16 take 3 is -19. I now use my difference of perfect squares. X minus 4 is my first term. And my second term will be plus the square root of 19 minus the square root of 19. And I'm done. That is factorized by completing the square. If you were asked for the turning point, you would go back to the second last step. That parabola is moving to the right 4, down 19. So its turning point is 4, -19. If you're asked to solve, you'd let all of that equal 0, and you'd have 4 take root 19 and 4 plus root 19.